and deflection of beams. Deflection of beams. Before going to the next topic, that is torsion and thin cylinders, then Euler buckling, we are going to revise a few things from these things. So in bending stresses, the main formula that we use is m by I is equal to E by R is equal to sigma by. I discussed few problems how to take these two at one time and these two as one time. So basically we need to obtain bending stress. Both suppose this is your bar, and if you just apply a couple like M, it will bend like this. So its top fiber is in compression because you can see the length is shortening, and this bottom fiber is in tension. So as you can see in the same beam, there is both compression and there is compressive stress as well as tensile stress. Okay, now this is now what the here I will term something. Suppose this is your circle, and if you just take R from the neutral axis, this is the value of R, and here 1 by R is called the curvature. So sometimes in exam you can they can directly ask find the curvature. So you need to find 1 by R. That is, I am writing. You are seeing it or not? Because here I cannot see the chat. Please speak. This is in Meet. You cannot see the chat. Can someone speak? Okay. Now the thing that we learned yesterday is M by I. You need to remember this because directly you can solve bending stress question from this. Only you need to know how to find the I, how to find M, and how to find Y. M Y by I, or you can also write it as M by I divided by Y, and it will be M by Z. So I by Y, that is Z, is called the section modulus. Section modulus. So just taking in separate terms, you can directly take as a Z, and it is section modulus. So suppose you have a square cross section beam. Suppose you have a beam, Z is equal to I by Y. Now what will be your I? 1 by 12 BH cube upon Y, that is H by 2. Maximum Y is H by 2 because the neutral plane will pass to the center of gravity. Similarly, for circle also you can obtain, for triangle also you can obtain, and for any shape. So the basic thing is you need to determine I and Y. So I just remember in previous year GATE they asked just like same question, normal question. So yesterday I told you how to proceed the problem. Suppose you are given a some UDL load, okay, and you need to find the maximum bending stress. So first of all, in UDL you need to know what is the maximum bending moment. So in order to make this quantity maximum, your My should be maximum, and you need to find the location where M is maximum. So in entire beam you need to draw the bending moment diagram. So UDL, it is a parabolic, and your maximum bending moment is W L square upon 8. Now this is the maximum bending moment, and at this plane, that is the center, the whole at this whole section, the bending moment will be W L square by 8. Now you need to take the Y maximum, and Y maximum can be H by 2 at the top fiber and at the bottom fiber. Top fiber is in compression and bottom fiber is in tension. So your sigma max will be simply WL square by 8, this is the maximum bending stress. Your maximum height will be h by 2 divided by I, that is dh cube by 12. So you can directly find the maximum bending stress. Now going to the unsymmetrical sections, that I also you take a T section. So just in rectangle, you know that neutral plane will be here in between, passing through the h by 2 distance. Okay, but in circle you also know that it will it is a r at radius. This neutral plane will pass through. But here you cannot know where the neutral plane is. So first thing, neutral plane always pass through center of gravity. So you need to find center of gravity or center of mass. So here the center of mass is, you need to find two masses are joined. So take this mass first, take this mass second. Okay, apply y bar is equal to a1 y1 plus a2 y2 upon a1 plus a2. You will obtain y bar. Now this y bar you take and obtain moment of inertia about that line. Suppose this is your y bar. Okay, this is your y bar from base. Take this plane, obtain the moment of inertia of the body. So suppose this is the this for let me change the pen. For this thing, this is your center of gravity and this is your y bar. So this distance is y bar minus y1. Now moment of inertia about that line would be, first of all, the moment of 1 by 12 b1 h1 cube. Okay, now shift the as you know in mechanics you studied shifting property of moment of inertia. So plus area, that is b into h into y bar minus y1 whole square. I hope you already know this. Now plus the second quantity, that the top portion. Top portion also has the same moment of inertia about the center line. So it will be 1 by 12 b2 h2 whole cube plus, now top portion distance, this from this neutral plane you have to take this distance. So that will be b into h b2 h2 y2 minus y bar whole square. So this is a moment of inertia. So now you obtain the moment of inertia, you obtain the y bar, not the go with the formula. What is the formula? My by I. So you obtained I, you have the value of m given, draw the bending moment diagram, you need value of y. Now maximum would be occur at either top fiber or at the bottom fiber. So take the distance, which distance is larger. So if this distance is larger, then there is a maximum here, and if this distance is larger, then the maximum. Any doubt up to this in bending stress, the basic division of the symmetrical and unsymmetrical sections? Yeah. Oh, okay. So you know how to find the center of gravity, na? So suppose this is your body. This is from the baseline. Suppose this is the datum that I am considering. So center of gravity of this figure, suppose this is h1, the height, and this is b1. Now this is h2. Take this distance. This is your y1. Okay, the half distance, that is h by 2. Now from the datum, the center of gravity of this figure, center of mass of this figure, and if you take this figure, your center of mass would be h plus h1 plus, so here the center of mass will be. So if you take this distance from the datum, it will be y2, and it is equal to, how to find the center of mass? Apply that y bar is equal to, suppose this area is a1, this area is a2. So a1 y1 plus a2 y2 divided by a1 plus a2. You got it now what I am saying?
Yes, sir.
Okay. So any other question in symmetrical and unsymmetrical sections in bending stress? if you can ask, it would be easy. So please. If problem, ask me in between. Otherwise, how we'll solve questions. Now, uh, as, so first, what is the bend? Suppose this is your beam. Okay, this is your beam. So what is the profile of bending stress? First of all, so you can see sigma is equal to my by I. So for a particular section, suppose I take this section. For a particular section, m is constant, I is constant. Okay, then your sigma is directly proportional to y. That means if this is your x and this is your y, now along the y, suppose this is x, this is y, at this particular section, your bending stress is directly proportional to y. And if this bending is like this, suppose this is the bending shape of the beam after bending. So the upper portion is tension, so there is a compressive stress, and the bottom portion is for elongation. So suppose I take this, this would be like a linear profile. So suppose this is your center line, neutral plane. So here this is a compression, this is compressive zone, or I can say this bottom portion is in tension and it is directly proportional to y. Means at the center line your sigma is 0, but at the bottom fiber and at the top fiber it is maximum, and it is this value is equal to m into h by 2 by I, and also m into h by 2 by I. Only sign is here it is compressive. Now this you learn about the how the bending stress is changing. So yesterday I uploaded your lectures that I taken, so you can see if any doubt was there. I discussed the questions also. So I shared the link yesterday, so if anyone didn't get it, please get it through ma'am or a person named Deepak. He has the link. Now second thing, shearing stress. So when I asked you draw the bending moment diagram, draw the shear force diagram. So bending moment creates your bending stress and your shear force creates the shear stress in beams. So shearing stress is B to draw for shear force. Okay, suppose for this type of support, what is the maximum shear force? You need to find. So formula is F into A into Y bar upon IB. So either go with this way, but in exam generally they don't ask such big things. Shearing stress contains very few questions in GATE. So I want you to remember only few things that I also discussed yesterday. Three things, and you have a triangle. These three things, these basic symmetry things, take their center of gravity, and what is the maximum shear stress? That is 1.5 times tau average, and tau average is equal to 1.5 into F by, suppose this is B, this is D, tau, and your F is your shear force at that particular location. For the circle, tau max is equal to 1.33 times tau average. Here 1.33 times tau average is F by pi by 4 d square. Okay, now here in this section, here what is the tau max? Here there are two things. The tau max doesn't occur at the centroid, it occurs at h by 2 distance. So at h by 2 your tau max should occur, and that is 1.5 times tau average. Okay, but at 2h by 3, that is the center of gravity, at center of gravity 2h by 3, tau at 2h by 3, it is 1.33 times tau average. So please remember this in exams. They will not ask derive this from these basic equations. Bending stress they can ask, but shear stress I remember these things only asked in the exams. And also, what is the profile? What is the Just I discussed in bending stress, it is linear. In bending stress, the profile is linear along the length. The profile is linear along y direction, and y direction, you know, along the cross section in y direction. But the shearing stress, the profile is parabolic. That means, suppose this is your section. So if I draw it in this plane, it will be a parabolic, and here at the center it is maximum, and at the top and the bottom is 0. But if you consider bending stress, this will like this. So at the center it is 0, and at the top fiber it is maximum. So this is bending stress, and this is your shear stress. So you need to know the difference. Now let us take a unsymmetrical section. Suppose okay. You don't need to remember the formula, because in shearing stress the formula is very difficult, because every other section you need to take, that's not like bending stress. So know how to draw the figure. So suppose this is a rectangle. So rectangle is a parabolic. So draw up to this line a parabolic parabolic shape. At the junction, the equation that we need to remember is, for this, suppose this is tau 1. So tau 1 into, suppose this is b1 and this is b2. Tau 1 into b1 is equal to tau 2 into b2. Means at this section, if you are considering this section, so suppose I got tau 1 here, and you have b1 divided by b2. So b2 is small compared to b1. So the tau 2 value is very large at this junction. Okay. Now again draw the parabolic profile. This is your shear stress diagram for this T section. Now going with I section. Now going with I section, suppose this is your I section. Okay. Now this is your I section. So draw a line. First of all, here it is rectangle, so it will be a parabolic. Then at this point there is sudden jump as a formula, tau 1 b1 is equal to tau 2 b2. So sudden jump here again. Sorry. Suppose this is your jump. Then again, because of the rectangle it is parabolic, so draw parabolic. And again, because of the increase in cross section, there is a decrease in stress. So come back again, and again parabolic. So you know how easily you can draw these things. So you don't need to remember how to derive, just remember how to draw the figures. So you can easily draw these figures. Also, in beams, in bending stress, there is a concept called moment of resistance. So moment of resistance. Moment of resistance is, suppose we used to consider this equation, but take m other side. M is equal to sigma I by y. So the maximum, this is the moment of resistance, that how much bending moment the beam is resisting. So how much bending moment the beam is resisting. The beam is resisting. So this is the moment of resistance. So sometimes in exam they can directly ask what is the moment of resistance of this beam. So you need you have given the sigma value, sigma, that is the material strength given, I also given, and y. You can directly find how much the bending moment a beam can resist. Okay, maximum bending moment. So this is the moment of resistance. So these things yesterday we discussed. Then we discussed deflection of beams. So in deflection of beams, what we discussed is method, that is conventional method, that is solve bending stress. And in exam you will not use this. This is very lengthy, means very lengthy. You should not use this. This you can use where the loads are complex, the loads are complex, you can use this. And there is moment area method. In moment area method, when the beams are not uniform, basically you can use moment area method, and it is one of the most easy method. So I yesterday, whoever he is in the lecture, I explained every 3 methods with the same problem, so you can see that in the recording. So I am just give you example with the cantilever beam, easy method. Okay, so I hope you are with me. Just say yes so that I can proceed further. You need to unmute yourself because I cannot see the chat. Okay, so suppose I have a cantilever beam, okay, like this with a point load P. Now from the double integration method, you know the equation is, so at S section the moment is P into X, negative direction. Okay, now if you double integrate it, then it will be EIY is equal to minus P x cube by 6 plus C1x plus C2. This is your equation, and your first integration will be EI dy by. Now what are the boundary condition to obtain C1 and C2? So take this section at x is equal to L, your dy by dx is 0 and your y is 0, because there is no deflection at this point and there is no slope at this point. So then you obtained your y value it is a function of x. Okay, you can obtain C1 and C2 and y. So the maximum deflection is occur at this point. So what is the maximum deflection? Y max, that you need to remember PL cube upon 3EI. And your maximum slope is occurring at this point. What is the sorry, not this point, at this point your maximum slope is occurring, and that is PL square upon 2EI. Now you know that it will go with double integration, then you need to find the constants. And now I am going to say the same question with moment area method. Suppose this is your beam and load is bending moment diagram. It will be in negative direction, and like that negative, and your maximum value is WL. Okay, this is your maximum value. Now you need to find the y maximum that occurs at this point C. Suppose this is C, this is A, this is C. You add C that occurs at this point and theta max at C. So you need to find this. So what the moment area method says, in moment area method it is saying that theta c, so you need to take that reference point where the theta is 0, so that you can directly get the theta c, otherwise the term will come in difference form. That is equal to the bending, this is the area of this shape divided by EI, that is the area of bending moment in between C and A divided by EI. So what is the area? The area is, suppose this is length L, so the area is 1 by 2 into WL into L divided by EI. So it is coming WL square, sorry, not W, it is P, P. It is coming. So you can see that going with the double integration and going with the moment area method, how easy it is. You need to only know how to draw the bending moment diagram and evaluation of the area. Okay, now what is y max? The y max should be, I am writing here, y max should be area in between points, in between the points you need to obtain, into x bar divided by EI. So in what is the x bar? You know area, how to find the area? The area is half into PL into L divided by EI. Now what is x bar? So suppose your delta C minus delta A, it is also the difference. Delta C the deflection at point C and delta is the deflection at point A. So take that reference point where deflection is 0. So I am taking delta A. Okay. Now what is x bar? Thus suppose this is your center of this is the center or centroid of this triangle. So what is the distance is 12/3 from the point C. So take this distance from the free end. So where you need to obtain, take the center of gravity or center of mass of the bending moment diagram from that distance or center of area. So it is 12/3 from that portion where you need to find the deflection. So the equation will become PL cube upon 3EI. So I hope you got it how the moment area method is very easy when compared with double integration method. And these Macaulay's method are used when loads are given very complex. So don't use it. Don't use generally. We avoid using it. And if something is given, you can take the example from the previous lecture. So these things yesterday I discussed. So anyone has problem in deflection of beams? Can anyone speak any problem, or you got it understand? Please speak, then I will move ahead. Can anyone say how deflection of beams? So I move ahead because after moving ahead, when you are solving question, it will be difficult for you. So I'm asking. So now we are going with torsion. Am I visible? My screen is visible. A torsion screen. I written. Okay. So suppose in bending, suppose this is a rod. Let me draw it in 3D. Suppose this is a rod. Okay. Now you know when you apply this type of load, it is bending. You apply suppose if I apply any load in the perpendicular direction to its center axis, suppose this is that center axis, and in perpendicular direction to the center axis, that is called bending. So bending can be applied in this direction, or any direction. But what is torque? Suppose this is your circle. I am just taking the section. Suppose you see from here, this is your eye, and you are seeing from here. So this is at this surface tangentially, and you have a P force at this surface tangentially. So it is forming a torque, means couple, and that couple will tend to rotate it like this, means you can say in clockwise direction along the axis. So this is called the torque. So this torque will create a twisting in the body. So if I say it demonstrated here, it will be like this along the surface. So you can say it like you are when untightening any box. Suppose you have a candy box and you are just applying force with your finger on that means what you say on the lid. So that is the torsion, and so it is equal and opposite tangential force will create a couple, and that is called the torque or torsion. So you know bending moment and you know torsion, the difference between the two. So here it is. Suppose this is a rod. This will tend to rotate the element. So what is the reaction at the ends? Because it is rigidly coupled, it is rigidly held in between. So if you draw the free body diagram, so in free body diagram what are our basic assumptions is remove the support first. So I will removing the support. So suppose this is your rod, I just remove the support. Now this torque is applied, then in order to rotate it you need to apply a counter torque, so that this will tend to produce a twist in this body. So what is the reaction at this fixed support? This you can say a clockwise torque. Okay, so this is the reaction at the support. Now for this type of body, the equation is just like the bending stress, what we write it, m by I is equal to sigma by y is equal to E by R. Here we write is as T by J is equal to tau by R is equal to C theta by L. Now what is the meaning of every component? Just like in bending stress I explained, let me go with it. T is the torque that is applied at the surface, J is the polar moment of inertia. So in here the I is the moment of inertia about the center line. Now here also about the center line, but it is the polar moment of inertia. What is the polar moment of inertia? This is your, suppose I draw a line at the center and take this as an axis. Suppose this is your Z axis. So IZ will be your polar moment of inertia. That means at the perpendicular direction. So if we take a circle, suppose this is a circle. Now this is your IYY, this is your IXX, but if in perpendicular to the Z plane, this is your IZZ. Okay, now this IZZ will be your polar moment of inertia. Okay, now what is tau? That is the shear stress developed in the body. So we found that torsion develops shear stress, and this shear stress is at what location? At location R from the center. So if okay, now if this is your circle, then at any distance R, suppose I take an R at this distance, sorry, at this distance R, okay, draw a circle, and at every point on the circle the same torque, the same shear stress is developed. Now what is C? C is the modulus of rigidity. Modulus of rigidity. Angle of twist. Angle of twist. How much this front surface is twisted with the reference line. Suppose earlier it was this much and you applied torque, and suppose this is your baseline. Now this baseline is shifted to here. So this is your theta. Okay, and L is the length of the rod. Length of rod. So just like we did in the bending stress, write it like it, sigma by J is equal to tau by R is equal to C theta by L. Now in bending stress, what is the strain? Just sigma by Y is equal to E by R. So sigma by, if we write it sigma by Y is equal to E by R, so sigma by E is equal to Y by R, and you know sigma by E is equal to strain from the Hooke's law. So here the strain is Y by R. Now take what is the strain, that is shear strain in this torsion. You take T by R, tau by R is equal to C theta by L. Now tau by C is equal to R theta by L. So tau by C is the shear strain. So shear strain is R theta by L in torsion. So just I am giving you why I am comparing with you, that this will help you to learn from the bending stress. It will not create something new. So T by C, that is the shear strain, we demonstrate it by gamma. Suppose I gamma is equal to R theta by L. Or and in bending this is your normal strain, that is equal to Y by R. Now in bending we called sigma is equal to My by I. So M by Z, Z is equal to I by Y, and it is called section modulus. Here In torsion, T by J is equal to tau by R. So tau is equal to TR by J, and that is equal to T by Z, and here Z is, sorry, I write ZP, otherwise you get confused, ZP, and this is J by R, and it is called polar section modulus, polar section modulus. So the basic concept is clear to you in the torsion. What is the shear strain, what is the modulus of rigidity, everything. Is it okay? Hello. So you need to know the formula. So first, suppose there is also a formula that is called power transmitted. I hope when you study SOM and study machine design, that will come. That is torque into omega. Okay, means that is that power. This is power transmitted, and in work done, it is T into theta. That is also half will come, but generally T into theta. Okay, so here that power is T into omega, the torque applied, and that is generating a angular velocity in the body. So the power is that is transmitted. Suppose your shaft is there, you connected one motor here. Okay, this is your motor, and you are driving something. Suppose you are driving some mechanism in your workshop. Okay, now if you so the torque that the omega that you are angular velocity given to the body, if you multiply it with the torque, that is the power transmitted. Now you generally the motor is giving a power, so you know P, that is V into I. So you know power, you know omega. So torque that will the torque that you are need to calculate is torque is equal to P by omega. So when you get the torque, apply the equation that is the torsion equation, C theta by L is equal to tau by R. You can get shear stress developed in the beam. So you know just from the power and you given omega, you will get torque, and that torque will put in the equation, you will get your shear stress in the body, and also angle of twist. What is the angle of twist produced in the body? So from the equations you just can get, you don't need to measure. So suppose the motor is supplied at a V voltage and given current I. So you can get the power of the motor divided by omega, you can get torque. Then torque you put in this equation, you can get shear stress and also angle of twist. So I hope you understand. If you got this understand, your means torsion is around 90% completed. Okay, every questions come from this only. Now some basic I need to use solve some basic questions. So before that, if anyone has any doubt, ask me, otherwise I will go to give you some questions. Any doubt, or I will start the question. Can anyone reply? I am going to start question because no one is replying, so I hope they got understand. So suppose you have a rod. First, the basic thing. This will come in MCQ in 1 marks or in PSUs in year C's. So suppose this is your body and you are applying torque. So if I draw, suppose you are seeing from here, this is your eye. So this is a circle. Okay, the cross section is. Now you are given a few points. 1, suppose this is your 1 point, this is your 2 point, this is your 3 point, and this is your 4 point, this is your 5 point. You are given which point have maximum shear stress, which point have minimum shear stress, minimum shear stress. So I need answers. Please someone say it is wrong or right. I'm not going to see their names, so don't worry. Say anything because this is MCQ type question. Can anyone say which point has the maximum shear stress? Okay, 0.5 minimum. What is the maximum? Okay, all over point has same because it is at the same radius r. So you know that tau is a function of r. So when r is 0, the tau is 0 at r is equal to 0. So minimum shear stress. That means at 0.5 r is 0, that is minimum shear stress, and at the outer surface it is the maximum shear stress. Now suppose, just putting this question a little bit complex, okay, or I should make it okay, leave it. I will a hollow shaft of 60 mm outer dia transmits power of 180 kilowatt, okay, while rotating at frequency of 25 hertz. So find the thickness of shaft. What is the thickness of shaft? So that maximum shear stress would be 60 Newton per mm. So use the equation T by J is equal to C theta by L is equal to tau by R. So I am giving you 1 minute. Solve the question. Answer is I am just telling the answer. The answer is your answer is 4.18 mm. 4.18 mm. Okay, it is 4. Don't get confused. So I am giving you 1 minute, 2 minutes. You can solve it. Please solve the question and match the answer is coming or not. First of all, your power is given. Power is 180 kilowatt. That is 180 into 10 raised to the power 3 watt. Okay, first write in everything in the favorable unit that you are familiar. Frequency is 25 kilohertz. What is the meaning of frequency? Frequency means in 1 second it is rotating at 25 what you can say 25 times. That is the meaning of frequency. It is called 25 per second, means in 1 second it is rotated 25 times. So that means its RPM, you can directly find RPM as 25 into 60, because in 1 second it is rotating 25. In 60 seconds what is the value? So it is 25 into 60. So what is the value? That is 1500 RPM. 1500 RPM. So, and you also know how to convert that RPM into that angular velocity, that is this is revolution per minute, 2 pi n divided by 60. So if you do that, 2 pi into 1500 divided by 60. You get the omega, that is the angular velocity. So now you get power, you get omega. So just I am taking the direct value of omega. What is the value? So okay, give me 157. Okay, 157 radian per second. So if you take power divided by omega, then the torque will come. That is the torque in the body that is applied. So 180 into 10 raised to the power 3 divided by 157 is the torque that is applied, and it is in Newton meter. The unit should be in SI because I have taken watt and I have taken radian per second. So the value will come in Newton meter, and its value is 1145.92 Newton meter. Okay, now you got the torque. So T you got, J you can obtain. Okay, what is J? Pi by 32. J is pi by 32 d outer ki power 4 minus d inner ki power 4. This is for the hollow shaft. I hope you remember in your mechanics course. So you take di as di. You need to find di only. So T by J, that is pi by 32 d outer power 4 minus d inner ki power 4. That is equal to shear stress, that is given 60 divided by the value of R. So maximum value of R is 60 divided by 2 because this is diameter. So outer dia has the maximum shear stress, so it will be 30. So you can directly find di here because it is given in the power of 4. You can directly find di. So di is coming 51.66 mm and your DO is given 60 mm. So suppose if I draw the body, suppose this is your body, okay, and this is your inner body. So your outer dia is 60 mm. So if you just take what is the thickness, so here is also T, here is also T. So di plus 2T is equal to DO. Therefore T is equal to DO minus di by 2. Okay, so the answer you will get is 4.17. So any problem in this question? Any problem in this question? But no one is responding. Okay, also given modulus of rigidity. Okay, modulus of rigidity, then you can also obtain the angle of twist. The screen is not visible. Is it visible now? Just wait a sec. Anyone else can confirm it is visible or not? Okay, so better the person who is seeing, please check your network connection. It will visible to you after that. Now if you are given the value of modulus of rigidity, you can also find the theta, means angle of twist in the body, angle of twist. So just it is a game of what is given and what you need to obtain. So if anything, suppose this is your equation, you can obtain shear stress if your C is given, your length is, torque is given, J is given. So in between whatever you have given, you can obtain, and also you can obtain shear strain also. Now what is shear strain? That I already told, it is R theta by L. So directly going with it, or it is tau by C. So you can go in both ways, tau by C. So these are the basic questions. So let me go with some little complex problems. Okay, now my screen is visible to that person. So can someone respond? They have already had studied these things in their college. I hope they studied that. I am going with some little bit tricky problem. It is series shaft and parallel shaft. Suppose it is given you have one shaft like this and it is connected to another shaft and you apply a torque here. Now what would you say this type of connections? Now suppose the same question like this. Suppose you have one shaft, you have another shaft. You just clamped it here and you apply torque at the center. So this is your series connection and this is your parallel connection. Okay, so in series connection, that is, suppose you deform this body by theta 1 and you deform this body by theta 2. So total deformation theta is equal to theta 1 plus theta 2. But in this connection you can joint it together. So both angle of twist should be equal. So theta 1 should be equal to theta 2, that is theta. Now here the torque is same, the torque is different, means it is distributed in between. Suppose I apply T, now T1 goes here, T2 goes here to produce the same angle deformation. So T1 and T2 are different. So this is the difference between series and parallel connections. So I am going with a question you will get easily understand. Okay, suppose this is your two bodies. It is given torque. The length is 1.2 meter here and it is given 1.5 meter here. So this diameter is 6. Suppose this is I am writing D1 and here writing diameter D2. So D1 is 60 mm and D2 is 50 mm. Okay. Now and also modulus of rigidity is given 8 into 10 raised to the power 4 Newton per mm square. Sorry, Newton per mm to power 4. And angle of twist, total angle of twist does not exceed 2.5 degree. Okay, so this is your question. Any data is missing? Yeah, torque data is missing, I think. No, we need to find the torque. We need to find the torque so that total angle should not exceed sorry, total angle should not exceed 2.5 degree. So I am giving you 1 minute. Please solve. Don't solve it, at least think about it. I am not asking you to solve, at least think. I explained the concept, that is this one here. What I explained, use this equation and also the torsion equation, T by J C theta by L tau by R. Please use this equation. So let me discuss this. I hope you go. So first of all, let's draw the free body diagram. The person, those who attend, distribute that in your body. Now I'm going to I hope you remember these things. Where I have, yeah. I hope you remember this question. So what I used to do is, my screen is visible. I just made the every system is in equilibrium, okay, Then I obtained indivisible elongation and I summed up. Suppose this is your AB, this is your BC, CD and DE. So this is a case of a axial tensile stress. Okay. Now here I am going to do the same. I am taking the both body as a separate body that you should know. Okay. Just like in axial tensile stress, if here P load is applied, then P load must here be applied so that body is in equilibrium. Now here torque T is applied. Okay. Now here no external torque is applying, so this need to be balanced so that the summation would be 0. So if I just coupled both the joints, so net torque should be in 0. And if this torque is applying in this direction, and opposite torque should be applied in this direction. I hope everyone got clear with this free body diagram. So not take separate bodies. This is one body. So this is torque is the same. So let me write it like this. Okay. Theta BC is equal to T2 L2 by CJ2. Now let me write it more clear so that you get understand. So here we can write is theta AB as theta A minus theta B, that is equal to, because torque is equal in both the cases, I am equating equal T1 and T2 should be equal. It is given L1 by CJ1. Theta B minus theta C is T into L2 divided by C into J2. Now add both the equations. You get theta A minus theta C, because B would cancel out and your torque and C would be common, and L1 by J1 is plus L2 by J2. So you know theta C is 0 because it is rigidly clamped. So where it is theta C, it is rigidly clamped. So theta C is 0. So you know theta A is equal to T by C L1 by J1 plus L2 by J2. Now you know theta A, that is 2.5 degree. Okay. You know C, value of C, that is given 8 into 10 to the power 4. You are given, you need to find the torque. You are given L1, you are also given J1, that is pi by 32 D1 raised to the power 4, and your J2 is pi by 32 D2 raised to the power 4. You know L2. So every quantity you know except T, you can directly find the T. So what is the value of T? Let me write directly the answer. It is 1.11 kilonewton meter. Okay. So anyone has any problem in this question? Please ask it. Hello. Hello. Can someone say any problem? Please speak. We have 18 people and no one is speaking. At least say it is okay, you got understand. So this is your series connection. Now I am going with parallel connection. Okay. So let's go with parallel connections. So this is okay. Now parallel connections. Parallel connection of shafts at P and Q. You need to find, that is, what is the TP and TQ. Okay. Please just I am giving you 1 minute. Please just use the concept of parallel connections and solve this question. The value should be Newton meter. For practice it will help you. let me solve this question. I hope those ever who want they solved it. So I'm going to just show you how to solve this question. So suppose that same thing. Draw the separate body diagram, free body diagram. Now let suppose I am applying T torque here, TP. Okay, I am applying TP torque here. So for this body to be in equilibrium and another torque TP will come here. Now a net torque T is acting here. So what is the net? So sigma T at this point should be T. Okay. Now I am applying TP here. So what would be the value of torque here? T minus TP. So that when I add both the terms, it will be T minus TP plus TP, that is T. Okay. Now here I need to apply T minus TP, so in opposite direction to TP, and here also it will be T minus TP for the body to be in equilibrium. So T minus TP is TQ. Okay. So if you can find TP, then subtract it from T, you can get TQ. So how to find the TP value? So if you see this body deforming in this direction and this body deforming in this direction. So at the junction, suppose this is a point Q dash. Suppose this is a point Q dash and this is Q. At the point Q dash, net angle of twist is 0 because it is a point that is net. I am talking about net. Not there will be angle of twist, but taking the both angle of twist, it should be 0. Okay. Then what is the meaning of that? If you write the equation, so theta should be equal to, if we write theta in terms of T and J, T1 L1 by CJ1, so for both the cases, theta should be equal because they are rigidly held. Rigidly held means the theta should be equal in both the cases. So T1 L1 by CJ1 should be equal to T2 L2 by CJ2. Now T1 is TP. If you write it like that, TP into L1. What is L1 given? 1 by CJ1 is equal to T2. What it is given? T minus TP into L2. What it is given? 2 by CJ2. Then you can sorry, J1, because J2 and J1 are same because they both are rods are same. You can write as TP is equal to T minus TP into 2. So you get TP is equal to it is 2 by 3 T. I hope you get it. So I got TP. Now what will be TQ? TQ is equal to 1 by 3 T. And you know T it is given, I hope, 500 Newton meter. So 500, it will be, if you just subtract it, it is 166.67 Newton meter. And your TP would be, the value is 333. I hope it is 333.33 Newton meter. So anyone has any problem in this question? Hello. So I am applying a torque in between T, and the value of the torque is given. It is not given. Okay. Now you need to find the value of the torque. Suppose so that the end reactions at these support the end reactions are equal. Means suppose this is A, this is B. So TA should be equal to TB. You need to find the torque T here. Okay. So because the body has different geometry, now your polar moment of inertia will change. So let's apply at this point and draw the free body diagram. Take different bodies. One body, your second body. Okay, now if any person has doubt in drawing the free body diagram, just ask me, because this is one of the most important thing in solving torsion problem. Okay, I hope no one has doubt. So sigma Ta plus T minus Ta, this is equal, so sigma is equal to T. So you are getting that value, so I am just, that's why uh, I think there is some mistake. Oh, sorry, there is some mistake. Let me erase this. And also no one has said, sir, a direction error is there. So it should be also above T minus Ta, and it should be below. Now why I just said that? Okay, now add both the things. You will get T minus Ta plus Ta. So earlier it was in the opposite direction, so it will not gonna same answer. In above question also I just made it wrong. It will be in opposite direction, T minus Tp. So this uh, okay. Now add that, you get T in the top direction, in the upward direction. Okay. Now at this point we have theta is equal, that is theta 1 is equal to theta 2. Okay. Now solve this, you get T1 L1 by Cj1 is equal to T2 L2 by Cj2. Now you know Ta, T1, that is Ta, L1 is given, L1 and L2 are same, so write it like this, C is given same. Now J has changed, for here the J is pi by 32, 75 raised to the power 4, and here it is by C into J2, pi by 32, 75 raised to the power 4 minus 60 raised to the power 4. At any distance from, oh, so this is your case, and now I am applying torque. You say that torque at any distance x from center. Okay, now you need to find where, uh, because as you can see here I am getting, because L1 and L2 are same, I know, but this value and this value are not same. That means it will not be equal, because if it is, it should be. So how we will solve this? So for that we will divide this problem in three pieces. Suppose this is one piece, this is second piece, and this is third piece. Okay, I hope everyone is getting that. So if I am applying uh, torque here, suppose this is Ta, so I am applying Ta torque here in this direction. Okay, now an opposite torque Ta will come here, or where should I let draw it from here? Suppose this is a distance x, so take that distance x, Tx torque here. So here it will be T minus Tx torque. Okay, how many of you get this and how many of you don't get this? Hello.
Sir, first diagram also that the same.
Yeah, in this diagram,
Okay, sir.
look here, just add this center, and for equilibrium this should be T minus Tx. And if this Tx is acting in this way, opposite Tx should be act in this way. So just this is from the same axial problem. If you remember that axial problem, three problems. Suppose I apply P load here, obtain deflection at this point, okay, and at this point, and need to be equal. So suppose this is A, this is your B, this is your C. So theta Ca should be equal to theta Cd. This should be equal. Now please concentrate little bit, because it will be, if you understand this problem, then you can solve any problem. How many of you getting this, how I am writing it? because theta c is equal to theta c minus theta a, and you can just simply add and subtract theta b. Okay, now this is theta cb minus theta ba. I hope now everyone is getting that. Okay, now theta cb, that L1 upon cj1 plus theta ba would be the same tx, but here now it is x. You assume by cj2, and here it is t minus tx into L1 upon cj2. Now as you know, there is one variable tx and there is one variable x, because in order to make the end reactions equal, tx should be equal to t by 2, so that the end reactions should be equal. Because here are at point A, your torque is tx, and at point D, this point, your torque is t minus tx. So this need to be equal. So this implies tx should be t by 2. Okay. Now you have a single variable x and you can solve for x. So I hope everything is given. T0 value is also not given. So you can I am going to write it in the upward here. So tx is t by 2 into L1 upon cj1 plus t by 2 into x upon cj2 is equal to t by 2 L1 upon cj2. So t by 2, how many of you getting this? If any problem, then please ask me, because this is one of the good questions, and here I am ending the series and parallel connections. Hello?
Sir,
Yeah?
sir,
Obtained the t at the center, so that end reactions are equal. But when we obtained, we found that because of this difference in the term, end reactions will not be equal. So I taken at any x distance. Okay, suppose at any x distance this torque is acting, so that the end reactions should be equal. So now our main objective is to find the value of x, so that Ta and Tb is equal to t by 2. I hope you get it now. Hello?
okay, sir. Yes, sir. In theta CD,
Yeah.
till the theta CD, can you take the L1 value, sir? It is not a L2 one.
Oh, sorry, yeah. This is not L1. It is L1 minus x. Actually, both L1 are L is equal. You can see that from here. This is equal. 625, 625. Okay. So that's why I taken L1. It is L1 minus x. I hope you get why I write it L1. Because both L's are equal. So I just take it L2 is equal to L1. Okay. But now x would be x by J2. You can write it x by J2, and you get if you put that x here, so it will be 2x. So it will be 2x by J2. What I want to say. Okay, don't worry. So this is your equation, and this will be your answer. Your x value would be, let me write the x value. Sorry. Yeah. So where I get it, or I should write in a separate page? What you want to ask? Okay. Okay, that's what I am saying, because it is getting little bit. Okay, let me write it again. Don't worry. I'm going to write here only. So you can say that theta c b plus theta ba is equal to theta cd. That implies tx into L1 by cj1 plus tx into x, that is the distance x it is acting, by cj2 is equal to T minus Tx into L1 minus x upon Cj2. Okay, now Tx should be equal to T by 2. That's what I proved earlier. So if I put T by 2 everywhere plus T by 2 into x by Cj2 is equal to T by 2 into x L minus x by Cj2. So T by 2 would cancel from everywhere, C would cancel from everywhere. So now your equation will become 2x by J2. Okay, this is the last question from this series and parallel connections. So any doubt in series and parallel connections, you can get through it, and if any doubt, please mail me if any questions related problem. I will share this lectures link, and also is Deepak is here? Hello. Today Deepak is present or not? I made one link of notes, so he is the only. If someone also wants, please mail me at my mail ID. I will send them the link. Okay, this is my mail ID. Please. Okay, please mail it me. Now, for varying torque, suppose till now I explained. Okay, before starting to this question, I am giving you 5 minutes break. Please take water and just refresh your mind. Then I will come. Please take 5 minutes break. Is it okay? Hello. Is it okay? Meet me after 5. Meet me after 5 minutes. Okay. So just I discussed series connections and parallel connections. Okay. Series connections and parallel connections, where I discussed how to obtain the end reaction couples and reaction torque, that means at the support and reaction torque. Or I also discussed how to solve series and parallel connection problems. Okay. Now let's go with varying torque. Just suppose if a body, just I explained in the series connection, one torque is I am putting here, one torque I am putting here, then the question will change and you have to solve for two different bodies. Okay, one body is here and your sigma of torque would be T, and reaction torque 2T would be here. Now suppose if I put 3 torque, so suppose I put 3 torque in this position, 1 torque, 2 torque and 3 torque. Okay, both every has equal values. So I remove this and here 2T and now again 3T. As you can see that the T is increasing in the direction going when because of the equal and reaction couple is 3T. Now if it is if this is, suppose n torque is happening suppose this is n torque, n times torque is happening, T1 T2 T up to n. So at the end reaction you have anti-torque at the end. Suppose this is a body, so divide it in n parts. Okay, now and then so on here anti, and therefore opposite of anti. Okay, this is your torque. How to solve? So for the indivisible body, apply that what is called the theta equation. So you can form the cumulative theta, that is sigma theta. Suppose this is now what I am going to discuss is, suppose you have a torque that is in the whole body, it is acting like this. Okay, means T is acting in the whole body up to length L divided by n times, and you can say that okay, at the end reaction it is nt, but it is acting per unit length. Suppose what I am writing is T per unit length. That, or I will write like this. Its value is torque per unit length. So at the end, what is the torque is happening? If you divide it by length, so at just like here, if you divide it by n times, so end couple will be your end couple will be your nt na. Now here if you divide by length, so your end couple will be the reaction couple that occurs at this point. I hope everyone gets it. If I divide the torque, if by divide there is n torque is applying on the body, and if I sum up at the end it will be nt. Now if I apply T torque per unit length, so what would be the end couple? It for that how we obtain theta. Suppose this is your given A, this is your given B. You need to obtain theta B. How we obtain that? Because now you cannot apply directly theta TL by Cj. Can anyone any guesses how to obtain that? Because it is unit applying per unit length. You cannot just divide it by length, just one take one unit sum up the whole body. So we need to form a function, and what will be the function? Suppose just like in UDL we used to do, related with UDL only. Suppose I am taking this dx element here. What is the end reaction couple here? This is your Tx, and for this dx length, what will be theta? D theta B. What is your d theta? It will be T into x, and what is the length of the element? Dx. Dx upon Cj. J is constant, so I am not putting a function of x. Now, in order to find the whole theta, integrate it from B to A, and x from 0 to L by Cj. So, if you just obtain the value, it will be like theta is equal to small t into x square by 2Cj. Okay, that means theta B to A would be small t into x square by 2Cj. Now you can also suppose this is given Tx. Your torque is given Tx square times, means it is forming parabolic path. That means it is varying like this. The torque is varying in a parabolic path. So you can also put integration Tx square dx upon Cj. That is varying from 0 to L. Then it will be Tx cube by 3 Cj. That is theta. So I hope you got clear what is the meaning of varying load. Any problem in this? Varying, it is not, you can say varying, it is uniformly torque, not varying, or anything you can just put in the equation. D theta is equal to in t function of x dx, t into function upon Cj. Okay, you can write like this. So I hope everyone is clear with it. Any guesses? Any doubt? Hello, is it okay? Am I connected or not? Is it okay? Torque value, because it is I explained here na. Suppose I take 3 elements, what will be the end torque? 3t na. Now if I am dividing it with if the length is divided with, suppose your torque is divided with the length. Now if you multiply it by x, then end couple will be Tx. Okay. So it is like a uniformly distributed load where the load is applied. Now when you sum up the load at the end, it will be W into L. So it is like that, T into X. So that is like that. Okay. Now with the torque portion I am over. Now there are few questions that came with combined torsion and bending. Means suppose you have a rod and maximum principal stress. So just I explained the first class, I hope you remember. When two unlike stresses come, then the concept of, I hope you remember, uh, in uh, in Mohr circle we use the concept. So here if you apply the bending stress and you apply the torque, then the concept of Mohr circle will come. So let me go with it. In general, there is not a alone action stress, there is not alone shear stress, there is not alone torsion, and also there is not alone bending. They occur simultaneously. Why you study in different way? Because you study them in a individual part, then you sum up all these things, you apply means sum up all these things, and then you solve the problem. When you go with machine design, it will act with the both the things. So you need to know how to sum up that, and that will go with the Mohr circle only. So is it okay? Now just I will like to explain one thing. Okay. Uh, and also suppose you also know axle in the vehicle. So the axle is provided just for the support is acting, that will create a bending moment. So it has two things, but axle only has a bending moment. So you can say that the axle is just not getting any torque but only bending moment, but your shaft need to design in both ways. So you need to learn how to take combined torsion and bending. So I am going with it, and if you see from here it is a circle. So please just for the basic concept I am going with the basics. So that is acting, and you call it MB, bending moment, and you applying torque, that is MT, twisting moment. Now you need to find the maximum shear stress, maximum principal stress, and everything. So let us suppose just I asked a example. Suppose you have 1, 2, 3, 4. Okay, 4 points, and center is at 5 point. So 1, 2, 3, 4, 5. So at one point, what is the value and the sign also? Okay, plus for tensile and minus for compressive. Okay, in tau it will be same, but here it will be plus minus. So at point 1, what is the value of bending stress? What is the sign of the bending stress? Uh, can anyone say? Hello? Can anyone respond? What is the sign of the bending stress at point 1? So at point 1, because it is a cantilever, so it will bend like this. So upper portion is elongating, so it is in tensile stress. So sigma is positive. At point 2, this is the axis of neutral plane. If you resemble, at point 2 there is no bending stress. It is 0. At point 3 it is negative. At point 4 it is again 0. At point 5 it is again 0. How many of you get it? Please please say. Any problem in this? Okay, and no one is any problem because no one is speaking. Now shear stress. In shear stress, what is the value at point 1? Same tau. At point 2 also tau, 3 point also tau, 4 point also tau, and 5.0. So we in bending and in torsion, suppose you are asked to find at point 1 what is the maximum shear stress. Okay, or at point 3 what is the maximum shear stress, at point 2 what is the maximum shear stress. So you can directly apply the concept of Mohr circles. So up to this, anyone has any problem in the signs and in the values? Hello? Is it okay? If you are writing in chat box, I can't see. Okay, please don't write in chat box. Okay, no one is also replying in chat box, so I'm going with it. Now, so suppose you need to find the maximum shear stress as 0.1. So first of all, what is the bending stress? Sigma mb into y by I. Okay, sigma. And what is the shear stress? Mt into r by j. So y would be here y. Let me write it in separate way. So let me write at point 1. At point 1, your sigma b would be mb into r, that is capital R, or it will write it d by 2 divided by pi by 64 d raised to the power 4. So it is 32 mb divided by pi d whole cube. Is it okay? Now at point 1, what is the shear stress? Tau at point 1. It is mt into d by 2 divided by pi by 32 d raised to power 4. It is 16 mt divided by pi d cube. This is your equation 1 and this is your equation 2. Now at point 1, if you draw the Mohr circle, what is the state of the Mohr circle? You have one sigma b, and you have another stress, that is 0. Now take this as pause. If you draw the Mohr circle like this, okay, and you draw a circle, this is your tau, this is your tau. So this point is sigma b, tau b, negative, it is 0 tau b. Okay, now what is the maximum shear stress? So maximum shear stress is the radius of the circle, as you can see. So radius of the circle is this much. So what is the radius of circle? If this is sigma by 2. Okay, and this is tau. So radius is equal to, radius square is equal to, apply Pythagoras theorem, sigma by 2 whole square plus tau square. That is, if you give it sigma by 2, it is 16 mb by pi d cube whole square plus tau square. That is r square, and that is also the radius of the circle. So r would be, I am writing in the upward, r would be 16 by pi d cube, okay, under root mb square plus mt square. Because if you write it value of tau is 16 mt by pi d cube whole square. So this is the radius of circle. So maximum shear stress, that is tau max, is 16 by pi d cube under root mb square plus mt square. Okay, now this is your maximum shear stress. That is the radius. Now, what is the maximum principal stress? Maximum principal stress. Maximum principal stress is point at this point. So you know this value. This is the radius. Okay, this is your radius, and this is your you can say sigma by 2. So if you write sigma max, that is sigma by 2 plus radius. Now what is the radius? Sigma by 2 plus 16 by pi d cube under root mb square plus mt square. So you are getting it as sigma by 16 by pi d cube mt plus under root mb plus mb square plus mt square. So this is your maximum shear stress. Anyone has maximum normal stress? Anyone has any problem in this? Please, this is one of the most important concept that will use in your machine design. Please ask if any problem you have. I will explain it again. Hello, is there any problem in this? Can anyone respond, please? Is there any problem? Okay, so please respond, because otherwise I will like teaching it alone. So, and there are 10 to 12 people and no one is responding. I don't know why. So your sigma max would be 16 by pi d cube mb plus under root mb square plus mt square, and your tau max is 16 by pi d cube under root mb square plus mt square. So this is your combined torsion and bending. Combined torsion and bending. So earlier I explained combined shear and tensile stress in Mohr circle. Now this is combined torsion and bending with the Mohr circle. Okay. So this is your maximum principal stress and this is your maximum shear stress. Please remember the formula. They will ask directly. And also one thing, you can also get something else. Let me give you what we can get. Sigma equivalent is equal to m equivalent into d by 2 divided by pi by 64 d cube d की power 4, that will equal to m equivalent 32 into 32 divided by pi d cube. So if you substitute in place of sigma max your sigma equivalent value, then you will get m equivalent is equal to 1 by 2 mb plus under root mb square plus mt square. So this is your equivalent bending moment when you apply combined torsion and bending. So this is your equivalent bending moment. Similarly, equivalent twisting moment would be substituted like that, and you will get mt is equal to under root mb square plus mt square. So please remember, these questions are also coming in exams, and if you give test series you will get they will ask equivalent test twisting moment, equivalent bending moment. So these are the formulas. So what we learned in combined torsion bending, let me write it. So what we learned here is, first of all, okay, this is hello. So I am writing here sigma max is equal to 16 by pi d cube mb plus under root mb square plus mt square. Tau max is equal to 16 by pi d cube mt square plus mb square root over. Your m equivalent is 1 by 2 mb plus under root mb square plus mt square, and your mt equivalent, this is mb equivalent, bending moment equivalent, it is under root of mb square plus mt square. So please remember this for these formulas for combined torsion and bending. Combined torsion and bending. Okay, this will come in your machine design also, but better to remember it here. So I am going with one question. Okay, yeah, here I am putting in the bottom. So the question is, this is your question. It is given a solid circular shaft of 100 dia is subjected to a bending moment M and twisting moment T. Okay, and it is given the maximum principal stress is 100 megapascal and also given the maximum bending stress due to M alone, that is the bending moment, is equal to maximum shear stress due to T alone. And you need to find the T, the torque that is applied. So please solve it. Think about it, how we can solve this. The equations are in front of you. Apply the maximum bending stress and maximum shear stress equation and then maximum principal stress equation. You can obtain the torque value. So I am going with it. I hope you just find it out how to solve it. So let me go with it. So a solid circular shaft of 100 dia is subjected to a bending moment and a twisting moment. The maximum principal stress. So what is the expression of maximum principal stress is? Sigma max is equal to half of mb plus under root m square plus t square. Is it not mb? It is only m. Okay, this is your first equation. And the value is given as 100 megapascal. So it is 100 into 2 is equal to m plus under root m square plus t square. Your first expression. So it will be 200 is equal to m plus under root m square plus t square. Your first equation, second question. Now it is given the maximum bending stress due to m alone is equal to maximum shear stress due to t alone. Now maximum bending stress due to m will be m is equal to m into d by 2 divided by pi by 64 d power 4, that is 32 m by pi d cube. This is your maximum bending stress, and maximum shear stress is also you can directly from the above 16 t upon pi d cube. Now both are equal, so sigma m is equal to tau m, that means 32 m upon pi d cube is equal to 16 t upon pi d cube. Now you can see that directly 2m is equal to t. This is your third equation. So if you put the value of 2m is equal to t or t is equal to m, you can directly get, let me write here. So you can directly get from equation 2 and 3, 200 is equal to m plus under root m square plus 2m square. Okay, that means m plus m under root 5. If you solve this, it's 4 plus 1 5. Now what is the value of root 5? It is around 2.23. Now add it with 1, it will be 3.23. 3.23 m is equal to 200. Now what is the value of m? M is 200 divided by 2.23. It is 89.44 Newton, I think mm. It is in megapascal, so it is Newton per mm square. So that means, yeah, okay, that will be in form of Newton mm. Something is missing. I just let me see anything is missing or not. So okay, now what is the value of your, oh sorry, there is a slight error. Sorry, this is the value of mt. This is not equal to 1 by 2. Okay, let me solve it again. That is equal to m plus under root m square plus t square, and that is equal to, if you write it like that, then that is equal to, take it equation 1. Now second equation is 2m is equal to t, that we already obtained. Put that here, and m is equal to t by 2, because we need to find the torque. Therefore 200 into pi into 100 raised to the power 3 upon 16 is equal to, so this is a question of combined bending and torsion. Anyone have any doubt in this question? Hello? Mt is taken as t. Actually, I just explained now. It is given that the maximum bending stress due to m alone is equal to maximum shear stress as due to t alone. So if you write maximum bending stress, what it will be? M into d by 2 by pi by 64 d raised to the power 4. That means 32 m by pi d cube. And if you take maximum shear stress, it is T into R by J, that is T into D by 2 by pi 32 d raised to the power 4, that is 16 T by pi d cube. So if this is equal, if, let me write, so if given that tau max is equal to, sigma max is equal to tau max, that means 32 m by pi d cube is equal to 16 t by pi d cube. So if you write it, 2m is equal to t. So that's why I came to this conclusion. Yeah, but the mt that I taken as t, it is a twisting moment. Here it is given what? Your twisting moment is t. I denoted it by t. So I could write it in that form, and your bending moment is m. Okay, so today just half an hour left before your lunch. So let us discuss what we just got it here, and after lunch I am going with energy methods. That is what is the energy associated with torsion, bending, axial strain. Then the questions on concept of thin cylinders, also thin spheres. So if time permits, we will go with Euler theory. Otherwise, on the next day. So first of all, let me ask you a question. How many of you are solving previous year gate? Don't go with test series, don't go with anything. The basic thing. How many of you solving the previous year question? Uh, any answer? The topic I studied, I made taught to you. Any I think no one is solving it, but this is your loss, because if you don't solve it, how you solve in gate? In cricket also, you need to practice first, na? Just the IPL is starting na from 18th in second league. They also practice before the match. They will not play directly in the match. So I will share my experience. The first thing is practice previous year. I am not forcing you to go with test series. Test series are very hard if you don't go with previous year gate. First go with previous year gate, previous year ESCs. Okay, don't go directly to test series. Make your concept strong. So please anyone respond, are they solving it or not? Okay, there are 12 persons in the group and only one is responding. Where is everyone? Now I am not asking it till now, but it is around 70% portions has been covered in SOM. Just wait a sec, I am coming. आ गया क्या भैया? I am asking how many of you are solving previous year gate question. Okay, so okay, so what I want to suggest is, if you are final year or if you haven't, this is your first time. If this is your first time, don't go with test series. Try to build concept first. You can also give test series before the gate paper with 2 months, 3 months from November onwards. First, build your concept. Build your. There are few previous year gate, previous year ESCs, and also there are few coaching books are also available. Make everything available with you. Solve as many questions as you want, and lots of content is available on YouTube. I am requesting you. Why I am requesting you? Because uh, I am not expecting anyone to get first rank, because it is or in the topper list or getting PSU, because everyone will not get it. But I want the average student to get in good NITs or IITs. I want that student to work hard. Look, smart students will get somewhere in their life, but average students should get what they want. So that's why I am preparing. So today what we discussed is, uh, first of all, we devise the basic concept of what we studied earlier, the bending stress and shear stress. So in the from Monday to Friday, I want everyone to solve what I taught in the last 4 classes. Okay, I want everyone to solve that bending stress, shear stress, deflection of beams that I revised today. Then I go torsion. Then in torsion, I defined a few topics like series and parallel shafts. Then your varying torque, and also then combined torsion and loading. Okay, then I need you to solve previous year questions from all these. And if any doubt is there, please mail me. I will solve your question, or in the next class I will discuss that part. In Monday to Friday, please solve, because I can insist you. I will not. This is your not school. Just I will okay. You can choose the government, then you can also choose your future also. I mean, I think that you are that much credible. So please, if you are eligible to choose the government, you are also eligible to choose your future. So please solve questions. This is my personal experience. I just in my first attempt I cleared the getting a stipend in your life. You are not dependent on your family. You can made your education by yourself. That is the least thing that I am talking about. You can get as many in PSUs or in. So for the average student I am talking about. So uh, so these things I talked about. So after that, after lunch, uh, there are few people in the civil also. So I am talking that in their syllabus also there is energy methods. I seen that stop. If they want to study energy method, they can, but in civil the syllabus is not there. So in mechanical we have energy methods, but and also they don't have thin cylinders. So in civil engineering, after lunch they can come if they want to study, or they can it is their wish only. Okay, now in mechanical I am going with thin cylinders, then energy methods. These two portions I will go. So let me go with one or two questions, so that because starting new topic will be like, so let me go with one or two questions. So given a question is given, that is, I want to use a bar of circular cross section of diameter 10 mm is subjected to a torque of 10 kilonewton meter. The angle of twist at A is, and the figure is like this. This is your and you have to find that angle of twist at point A, and your given G is equal to 1 into 10 to the power 5 megapascal. So I want everyone to solve this question at A point. I am giving you 2 minutes. If you solve, then I will explain. Hello. Anyone has attempted? What is the value? Let me see. Someone raised his hand. Any value? Any answer? Okay, let me solve this question. So it is given that you have a body, so you can see that up at point B the torque is applying. So after that the body is not twisting. So you can say that, if suppose if I write it theta A minus theta C, now that is equal to theta A minus theta B plus theta B minus theta C. Now you can see that theta C is 0, okay, but it is also there because suppose what is this? This is theta AB minus plus theta BC. Theta AB can be calculated as mm, T into L by Cj. But here there is no any support so that resisting couple will act, and also no any torque at the end. So in that means there is no torque in between B to A. Now here on that means theta AB is 0. That means you need to find theta BC. Theta BC is equal to T. What is torque? 10 into 10 raised to the power 6, that is Newton mm, into L. What is the value of L? I haven't given the value, and no one even asked what is the value. I think no one is solving. 2 meter, 2 meter. So this is your torque into length, that is 2 meter, divided by T into L by Cj. C is 10 raised to the power 5 into J, pi by 32, 10 raised to the power 4. So your angle of twist theta BC, that is equal to theta AC also, because theta AB is 0. This is 1.17 degree. Okay, this is your answer for theta AB. Sorry, AC. Anyone has any problem in this question? Okay. So there is no any support here. Okay. So just apply the torque any support. So that will resist the bending. So a anti-couple will generate, but there is no any support. So that thing will be eliminated, and also there is no any torque in this portion. So that means up to the deformation would be in this body, and it will only follow the path. What is the meaning of that? That it will suppose this is your body. Now only this body will twist up to B. Suppose this is your C, this is your B. Now B will twist and A will follow the same angle of twist that B has. So the main concept is theta B should be equal to theta A. That is what I have written. Theta BC should be equal to theta AC. Because no any couple is acting in between, hence no any change in angle of twist. I hope now you got it. Hello, is it okay? Okay, now you have after lunch you have to come. What is the timing? It is, I think, 2:30. Let me check. Yeah, it is. And please solve the questions. And let me give you the